Hello. Now we're going to discuss linear inequalities. And when we think about that word inequality, we need to make sure we understand what that means. So an inequality is a symbol that would be used like an equal sign, but is not equal to, such as greater than, less than, greater than or equal to, less than or equal to, or not equal to. And so when we are dealing with inequalities, that means the solution is going to be a set of numbers, not just one specific number. So a linear inequality in two variables, ax plus by equals c. So a, b, and c are all elements of the real number system, and a and b cannot both be 0 because otherwise we wouldn't have a variable there. So we need at least one variable. If a was 0, the x would be gone, and if b was 0, the y would be gone. So we have some variable, x or y, or some combination of them with an inequality symbol, and it could be any of these 5 symbols in relation to some number. So the solution set of an inequality is the set of all ordered pairs that would make it true. So when we think about visualizing or solving these problems, we're really going to be drawing a graph and we're going to be shading a region. When we think about drawing the graph, if we have a less than or a greater than without the equal to symbol, we're going to need to make sure we have a dashed line. Whereas if we can include the value, if we have less than or equal to, greater than or equal to, we would need a solid line. So let's just jump right in and look at an example. Let's graph this linear inequality. Here we have y is greater than x minus 3. Now, one thing to note, we have a greater than symbol, which does not have an equal to included. That means we know whatever line we draw will need to be dashed. So that's what the symbol is telling us. So when we think about graphing, we just want to make sure we graph the related linear equation. So we have y equals x minus 3. You'll notice we have a slope m. The coefficient on x is 1 or 1 over 1. And my y-intercept b is negative 3, which gives us 0, negative 3 as my y-intercept. So I merely need to choose 0, negative 3 on my y-axis, and then I'm going to travel along the path of my slope, up 1 over 1, up 1 over 1. So we have a slope of positive 1, which would be marking these points. Or we could go down 1, negative 1, left 1, negative 1. And then when we draw our line, we just need to make sure that it looks like a dashed line. So we have a dashed line. Now, the solution to an inequality is the set of all points that would make this a true statement. And all you need to do to find that set of points is to choose any test point. That says chose. We need to choose a test point. There should be 2 O's there. So choosing a test point, I generally choose the origin, right? The origin is 0, 0. The only time you cannot choose the origin is when the line is passing through the origin. So again, repeating myself, you can choose any point as long as it is not on that line. So I'm choosing the origin because that 0, 0 is just the easiest for us to deal with. So if I choose 0, 0 to test, well, y being 0 is greater than 0 minus 3. That simplifies to the fact that y is greater than negative 3, a true statement. That means the solution is any point, any ordered pair in this region I'm shading sort of above and to the left of this line. So any point over here in the blue region would give us a solution. Any point over here would not be a solution. Are you allowed to choose a point on the line? That would be no, because it is a dashed line. It's not equal to the line. So this line represents a boundary that we do not touch. And again, any point in this shaded region would give us a true statement. So if I picked a point up here, I'm just randomly guessing it, that is somewhere like -8, +8. Let's plug that in. 8 is greater than -8 minus 3. That gives me 8 is greater than -11, which is again a true statement. So as I said, any point in that shaded region would be a solution. And we're shading right up to the line. When you are working on this on the homework, when you graph your line in the computer, you have the option to toggle between solid and dashed, and then you use a paint bucket to just click on the one side where the solution occurs. So you're not shading multiple regions. There's only going to be one shaded region in your answer. As always, please feel free to email me with any comments or questions or concerns because I want to help you.